Hello students, in previous lecture we have studied different type of voltage regulators beginning with Zener regulator, IC LM317 voltage regulator, transistorized voltage regulator, and at last in previous lecture we have studied switched mode power supply. Now in today's lecture we are going to learn about different types of problems on Zener regulator and IC LM317 voltage regulator. Now let's begin with Zener regulator. Before starting different type of example, let us revise some terms related to Zener regulator. That terms are, first one, RS. This is the series resistance. While the current flows through this is IS, IZ current through this Zener, VZ voltage drop across this Zener, IL current through this load resistance, and VL voltage across this load resistance. How to calculate this RS? VS minus VZ means the voltage across this series resistance minus voltage across this Zener, that is nothing but V upon I is the IS is nothing but the current flowing through this series resistance. This whole terms related to Ohm's law, V is equal to IR, and only abbreviations are used here, where IS is a current from unregulated power supply. Now by rearranging this equation, instead of IS here RS is present, we will get the value of IS, where IS is IZ plus IL, means this current is given by the current through this Zener diode plus current through this load resistance. Okay students, remember all these terms, these are necessary to solve the next problem. Okay, now let's start. Students, listen carefully. Any problem given in the exam, before starting the solution you have to read the problem carefully and observe the terms, which terms are given and what we have to find in the problem. Okay, now calculate the load current IL and Zener diode current IZ if breakdown voltage of the Zener diode may be assumed to be 5 volt. Observe this diagram carefully. Here this is a 20 volt VS. This 5 volt is given here VL. 1 kilo ohm, this is a value of RS, while 1.2 kilo ohm, this is a value of load resistance. Now what we have to find out? We have to find out the value of IL, then IS, and at last we have to find out IZ. Now by using Ohm's law, IL is equal to VL upon RL. Value of VL is equal to 5 volt upon RL 1.2 kilo ohm. By putting the value, then we'll get the value of load current IL is equal to 4.166 milliampere. Because this 10 raised to minus 3 goes to the numerator, it will turn 10 raised to minus 3. Then IS is equal to VS minus VL, as I have revised in the previous topic. IS is equal to VS minus VL, means it is a difference of voltage across this series resistance and voltage across this load resistance. So VS minus VL upon this value of the series resistance. So by putting the value 20, this is value of VS minus VL upon value of RS, it is 1 kilo ohm. Simply we'll write 10 raised to 3. 20 minus 5 is equal to 15. This 10 raised to 3 goes to the numerator. It will turn 10 raised to minus 3. So the value of Is is equal to 15 milliampere. Now we have to find out Zener diode current, that is Iz is equal to Is minus IL. Means for this formula we have to calculate these both terms. Okay. So Iz is equal to Is minus IL. Value of Is is equal to 15 milliampere and IL is 4.166 milliampere. So by subtracting both these terms we will get 10.834 into 10 raised to minus 3, and 10 raised to minus 3 is nothing but milli. Okay. So Iz is 10.834 milliampere. Students, this problem is asked in board exam March 2001 for 3 marks. Now let us see how these 3 marks are divided in this problem. This is first term IL. Correct formula half mark. Correct answer half mark. For second term, correct formula half marks. Correct answer with proper unit half marks. Then at last this Iz, correct formula half mark, and final answer proper answer with proper unit half mark. In this way total marks 3 divided in this problem. So you will get the full marks for each problem, each correct formula, each correct answer with their units. Okay student. So remember how these 3 marks are divided in this problem for each and every term and solve accordingly. Okay students. Now students, this is second problem. This is quite different problem than the previous problem. We have to find out Rs, IL and Iz. Okay. Calculate Rs, IL and Iz from this diagram. In this diagram you can see this 15 volt. This is Vs, 50 milliampere, Is, then RL 900 ohm, and voltage across the Zener is equal to 9 volt, and we know that the voltage across Zener is equal to voltage across this load resistance VL, and that is 9 volt. We have to find out these 3 terms Rs, IL, Iz. Okay. Now solution. By using Ohm's law, IL is equal to VL upon RL. By putting the value of VL and RL, 9 upon 900, that is equals to 0.01 ampere. And this 0.01 ampere is converted into milliampere. Therefore, load current IL is equal to 10 milliampere. Okay students? Now, we know that Is is equal to, that is a current flowing through this series resistance is equal to current through this Zener diode plus current through this load resistance. So by rearranging the equation we will get Iz is equal to Is minus IL, and we know that value of Is is equal to this is 50 milliampere minus this IL is equal to 10 milliampere. By putting the value 50 into 10 raised to minus 3 minus 10 into 10 raised to minus 3. By taking out 10 raised to minus 3 common, 50 minus 10 will get 40. So 40 into 10 raised to minus 3 is nothing but 40 milliampere. So this Iz is equal to 40 milliampere. Now we have to find out the last term, that is series resistance, and we know that by using Ohm's law, the difference of the voltage across this series resistance and voltage drop across the Zener upon the current through this series resistance, this ratio gives the value of series resistance. Therefore Rs is equal to Vs minus Vz upon Is. So Vs is given here it is 15 volt. Then VZ 9 volt. IS, this is 50 milliampere. Therefore, by putting all these values, we get 15 minus 9 upon 15 to 10 raised to minus 3. Therefore, 15 minus 9 is equal to 6 upon 50 into 10 raised to minus 3. So, by calculating this, we'll get RS is equal to 120 ohm. Now, this problem is asked in October 2001 board exam for 3 marks. So, distribution of marks will be half mark for correct formula, half mark for correct answer with proper unit. In the same way, half marks for this second term, half mark for correct answer with proper unit. Here again, half marks for formula and half mark for correct answer with proper unit. Okay, students, I think all of you can do more practice at home for solving these problems. If you have any doubt, feel free to ask me. Now student, this is homework for you. Problem number 3. In a Zener diode regulator, if source voltage is 25 volt, RS is equal to 1 kilo ohm. This 25 volt, RS is equal to 1 kilo ohm, RL is equal to 1.5 kilo ohm, and VZ is equal to 6.2 volt. Then calculate the Zener diode current and load current. Okay students? Understood all of you? Okay. Then this problem is asked in the board exam March 2007 for 3 marks. So this is most important problem board exam point of view. So solve at home and send me on my personal WhatsApp number. Okay students? Now students, next problem is on this variable adjustable voltage regulator. Means the voltage regulator using IC LM317. So remember these two, R1 and R2, both the resistors are different. This R2 is variable, this is fixed. Okay. Then with the help of this diagram, you will get a clear idea, and this revision of the topic of LM317 voltage regulator, you have to remember the formula V0 is equal to 1.25 into bracket 1 plus R2 upon R1. Okay students? So remember this formula for next problem. So this is the quite different problem than the Zener voltage regulator. This diagram also different. This is LM317 adjustable voltage regulator. Value of R1 is given. It is 100 ohm. Okay. Input is applied to the pin, and this is output is taken across this next pin, and this R2. In above IC LM317 voltage regulator circuit, find the required value of R2 to obtain an output of 12.5 volt. Means the expected output voltage also given here. So what we have to find out? Only value of R2. Now let's start. If we have to find out the value of R2, okay, then we know the formula as discussed previously. V out is equal to 1.25 into bracket 1 plus R2 upon R1. Value of V out is given in the problem. This is 12.5. Okay. Then 1.25 into bracket 1 plus R2 upon R1. Value of R1 is 100 ohm. Okay. It is given in the diagram. So by putting all these value, here 12.5 upon 1.25. This 1.25 is multiplied here. Then in the next term it will be divided. Okay. So 12.5 upon 1.25 equals to 1 plus R2 upon 100. This will give 10 by calculating both this. 10 minus this 1 is added here. By transferring at the left side it will subtracted, equals to R2 upon 100. So 10 minus 1 is equal to 9 and this R2 upon 100. This 100 is divided here. Now it will be multiplied. Therefore R2 is equal to 100 multiplied by 9. Therefore value of R2 is equal to 900 ohm. Is that clear, students? So in this way, this is so simple problem, but you have to remember this formula. This problem is asked in the board exam October 2007 for 3 marks. So mark distribution will be for correct formula half mark, for correct formula 1 mark, for correct formula 1 mark, for putting proper value for each term 1 mark, and for correct answer with proper unit 1 mark. Okay, student? So in this way you can solve this problem and you will get the full marks. Okay, students? This is a quite different problem than the previous problem. In this problem, you have to draw the diagram by finding the value of R2. Okay, students? Let us see. Draw a neat circuit diagram of an adjustable voltage regulator using IC 317. Find value of R2 if Vout is equal to 12 volt and R1 is equal to 1 kilo ohm. Also, specify output voltage range for IC 317. Now, before starting the solution of this problem, we have to write the given things. So, given things are R1 is equal to 1 kilo ohm, Vout is equal to 12 volt. And we know the formula Vout is equal to 1.25 into bracket 1 plus R2 upon R1. So 12, it is a given output voltage 1.25 into bracket 1 plus R2 upon 1 into 10 raised to 3. Therefore, by shifting this 1.25 to the left side, 12 upon 1.25. This is equal to 1 plus R2 upon 1 into 10 raised to 3. Now by subtracting this 1 from this term, 12 upon 1.25 minus 1, that is equal to R2 upon 10 raised to 3. So R2 is equal to this. By solving these both terms, will get 9.6 minus 1 into 10 raised to 3. This 10 raised to 3 at the denominator by shifting this to the left. So, we'll get R2 is equal to 9.6 minus 1 into 10 raised to 3. So, by subtracting this one, we'll get 8.6 into 10 raised to 3. Means R2 is equal to 8.6 kilo ohm. Understood all of you? How to find out the value of R2? By using this formula. So in this way the value of R2 is equal to 8.6 kilo ohm. Now this is first part of the solution. What about second part? In this second part we have to draw the diagram. Students, this is so simple because we know the value of R2 and value of R1 is given in the problem. So, this IC LM317 is nothing but a voltage regulator and R1, R2 both resistors are present, and as we know that only capacitor is necessary to connect this IC with the help of this bridge rectifier's output. So, this is so simple. You have to draw this bridge rectifier with AC input and transformer then capacitor. This IC LM317 has only 3 pins, therefore this is input pin, this is adjustable and this is output pin. Is that clear, students? This pin is grounded here. Okay. In this way, this is a complete solution of the given problem. So students, this problem is asked in the board exam March 2011 for 4 marks. Distribution of 4 marks will be like this. For correct formula, 1 mark. For putting proper values, 1 marks. Then, for finding the value of R2 with proper unit, 1 mark and 1 mark goes to this correct diagram. Okay. In this way, you have to find out this proper solution for proper step to get full marks. Okay, students. Some of the student will bother about that, how to draw this diagram, how to find out. You have to only know the formula of this V output is equal to 1.25 into bracket 1 plus R2 upon R1. So simple formula. And this is a bridge rectifier circuit. You have to connect only capacitor, and you know that this IC has only 3 terminal, 1, 2, 3, and as in this formula you can see R2, R1 and V out. So this is V out and R1 and R2 are here. So don't bother about this diagram. Let's remember that you have to follow each step in the proper sequence. This is a bridge rectifier. For example, this is a AC input, then transformer, bridge rectifier, capacitor, IC LM317, then output with the help of this R1 and variable R2. Okay, student? So, if you will do the more practice, then easily you can solve any problem related to voltage regulator using Zener or voltage regulator using this IC LM317. Is that clear, students? Now take this one more example for homework. 3-terminal adjustable voltage regulator using IC LM317 gives 10 volt output voltage with R2 is equal to 7 kilo ohm. Determine value of R1. Also draw a neat circuit diagram. Students, this problem is also asked in the board exam October 2011 for 3 marks. Only I have added this question for drawing the circuit diagram. So, you will get the more practice. Okay, student? Now, in this way, today we have practiced more problem about Zener voltage regulator and IC LM317 3-pin voltage regulator. Okay, students? In this way, in this chapter, we have studied block diagram of DC power supply, different type of rectifiers, their comparisons and problems, then different type of filters, their advantages and disadvantages, and at last we have studied that voltage regulator like Zener as a voltage regulator. Then to overcome some drawback, there is a next voltage regulator, that is a transistorized voltage regulator. Again, to overcome the drawback in the transistorized voltage regulator, there is a current limiting transistorized voltage regulator with the help of transistor T3. Yes. Then next is a IC LM317. This is a 3-pin voltage regulator with inbuilt thermal shutdown and current limiting action and heat sink capacity. Then last is a SMPS, that is a switched mode power supply. Students, remember that in SMPS negative feedback is used. Okay? In this way, today we have finished finally chapter number 2 with all problems and all the topics. Okay, students? This is enough for today's lecture. We'll see in the next lecture transducers from paper 1. And all of you be ready for practice unit test. Okay, I'm going to conduct practice unit test in the next week. Okay students, thank you.